Welcome to this guide on implementing an async loading system with an animated progress UI in Unity 3D, leveraging Visual Studio. This tutorial will walk you through creating a seamless scene transition experience. Efficient scene loading is crucial for a smooth user experience, preventing jarring pauses and keeping players immersed. Without it, frustration can quickly set in. Traditional synchronous loading methods can freeze your application, leading to noticeable delays and a poor user experience, especially with larger scenes. Asynchronous loading allows your game to remain responsive while content loads in the background, providing a seamless transition between environments and keeping the player engaged. Our goal is to construct a robust system that loads scenes asynchronously and provides clear, engaging visual feedback through a custom-designed, animated progress UI. To begin, set up your Unity project. Open Unity Hub and create a new 3D project, naming it Async Loading Demo. Within the Unity editor, we need at least 2 scenes, a main menu and a game scene. These will serve as our origin and destination for the asynchronous load. For our main menu scene, add a basic UI canvas. On this canvas, place a simple button to trigger the scene loading sequence. Rename this button to Load Game Button and change its text to Start Game. This makes its purpose clear. Next, create a new C# script named Scene Loader in your Assets folder. This script will manage all asynchronous loading logic. Double-click the Scene Loader script to open it in Visual Studio, where we will write our scene loading code. Inside the Scene Loader class, define a public method called LoadSceneAsync that accepts the target scene's name as a string parameter. This LoadSceneAsync method will initiate a coroutine, essential for handling asynchronous loading smoothly without freezing the application. Define the Load Your Async Scene coroutine, which returns an IEnumerator and encapsulates the core logic for asynchronous scene loading. Within this coroutine, use cmanager.loadSceneAsync to begin the asynchronous loading process, which returns an async operation object. Set operation.allowSceneActivation equals false to prevent the scene from activating immediately, giving us control over the transition and allowing for our custom progress UI. Employ a while loop to continuously monitor loading progress until the asynchronous operation is fully completed. Inside this loop, access operation.progress to retrieve a float value from 0.0 to 0.9, indicating how much of the scene has loaded. Once operation.progress reaches 0.9, set operation.allowSceneActivation equals true to activate the scene, as it is fully loaded but inactive. Always include yield return null at the end of each iteration within your while loop to prevent the game from freezing during loading. After saving Scene Loader, return to Unity. In your main menu scene, create an empty game object named Scene Loader Manager to host our loading script. Drag your Scene Loader script from the project window onto the Scene Loader Manager game object in the inspector to attach it. Select your Load Game button in the main menu scene. In the inspector, locate the OnClick event section to define its action. Add a new event slot to the OnClick list. Then drag the Scene Loader Manager game object into the object slot to establish the connection. From the function dropdown, select Scene Loader and then Load Scene Async. Enter Game Scene as the scene name in the parameter field. Before testing, ensure both Main Menu and Game Scene are added to your build settings by navigating to File, Build Settings. Drag both Main Menu and Game Scene into the Scenes and Build list to make them accessible for loading. Now, create our animated progress UI. In the Main Menu scene, add another UI canvas specifically for the loading screen. Inside this new canvas, add a UI image for the progress bar background and another UI image for the dynamic fill of the progress bar. Select the progress bar fill image. In its inspector, set image type to filled and fill method to horizontal for animation. Initially, set the fill amount property of your progress bar fill image to 0, ensuring the progress bar starts empty. Create a new C# script named Loading Screen UI and attach it to your Loading Screen Canvas game object to manage visual updates. Open Loading Screen UI in Visual Studio. Declare public references to your progress bar image component and an optional text element for percentage display. Add a public method named UpdateProgressBar that accepts a float, progress, and updates the fill amount property of your progress bar image. Within Update Progress Bar, update the percentage text display using percentage text.text equals .toString plus % for clear numerical feedback. Return to Unity after saving Loading Screen UI. Assign the progress bar fill image and your UI text element to the respective public fields of the Loading Screen UI script in the inspector. Now, integrate these UI updates into our Scene Loader script. Reopen Scene Loader in Visual Studio to connect the pieces. Add a public reference to our Loading Screen UI script within the Scene Loader class. Public Loading Screen UI for cross-script communication. Inside the Load Your Async Scene coroutine, activate the Loading Screen UI by calling Loading Screen UI a GameObject that's set active before the while loop. Within the while loop, continuously call Loading Screen UI.update progress bar to update the progress bar and percentage text in real time. After the while loop concludes and the scene is activated, deactivate the Loading Screen UI by calling Loading Screen UI a GameObject set active to complete the transition. Save Scene Loader and switch back to Unity. Assign the Loading Screen UI GameObject to the Loading Screen UI public field of the Scene Loader Manager script in the inspector. Initially, ensure your Loading Screen Canvas GameObject is inactive in the main menu scene, only becoming active programmatically when loading starts. Now, test the system. Play the main menu scene in the Unity editor and click Start Game to observe the process. You should see your animated progress bar smoothly fill up and then seamlessly transition into the game scene, demonstrating successful asynchronous loading. For testing, if scenes load too quickly, simulate longer times by adding yield return new wait for seconds inside your while loop for debugging. To confirm game scene loaded, add debug log in its start method. This message will appear in the Unity console upon activation. Consider creating your loading screen as a reusable prefab to easily integrate the animated progress UI into multiple scenes, saving development time. For advanced scenarios, explore loading multiple scenes additively or managing complex asset bundles asynchronously for greater control and efficiency. This foundational async loading system provides a robust starting point for creating responsive and engaging user experiences in your Unity games. Experiment with different UI animations, visual styles, and loading indicators to match your game's aesthetic and branding. Customization is key. Thank you for following this tutorial. We hope this guide empowers you to create smoother, more professional, and enjoyable game experiences. Happy developing!